Hello everybody. When we decide that a quadratic function is appropriate for modeling a situation, there's a lot of very useful things that different parts of the quadratic function can tell us about the situation that we are choosing to model. So we're going to answer some questions that the model would be able to help us find. The first question is we're going to predict the fuel economy of a car traveling at 80 miles per hour. Previously, we used quadratic regression to find a function that models all of these data points and approximates a parabola that passes close to those points. But you could be possibly given a formula to use that's a quadratic function, or you might just be given the quadratic function. So there are different ways that you could possibly come up with a function like this. But regardless, one of the most important things to pay attention to is what the variables represent. It is imperative that either A, you've precisely defined those before you begin doing the problem, or B, you read carefully what they are if the problem already defines them for you. You really have to read it carefully and not just gloss over it. You'll notice here that x represents the speed in miles per hour, and since we're given that the car is traveling at 80 miles per hour, that tells me that x equals 80. So this is going to be a problem where we're given an input value and going to be asked to find the output. So in order to do that, I could simply take the 80 and input it into my function. So I'll have negative 0.008 times 80 squared plus 0.746 times 80 plus 13.472. And now I'll just go to my handy dandy calculator, go to my home screen, and I'm typing it in. And so there's our answer. Let's just keep in mind that that's there. I'm going to show you another approach to doing this before we actually answer the question. But your graphing calculator also has features that can help you find it. So you'll notice in the previous video, when we actually found this function, we had typed this into our y equals screen, and you could do this with any function for any type of problem. But here's the function that we got from before, and I'm going to go to the graph, and I'll notice that my window is not good right now. First off, just like always, you should have hit zoom 6 to default your window to the standard viewing window. However, we'll notice I only see what looks like part of a line going up, and I know it should be a U shape, a parabola, and because of the negative value of A, it should be a parabola that opens downwards. So let's go back to our function. One, I noticed that the y-intercept is around 13. So that's usually a big hint of how high to make the window. But conveniently in this problem, we have a lot of data points in our table. And if I look at all the data points, I'll notice the y's top out around 30 and my x's go up to 70. So I'm going to set my window so I can see a little wider and a little higher than that. So to move it to the right more, I'll increase my maximum x to 100. and count by tens on the x-axis. And then I'll also increase my y maximum to 50. And remember that you could have different values as long as you're able to see the information you're able to see, then it's a good viewing window. So now I'll check out the graph. And I can see most of my parabola, so that's a good sign. Depending on what the question's asking for, will determine whether or not this is an acceptable window. But for now, I can see most of it, so we'll go take a look at the questions, and this might be sufficient. Before, we've gone to second trace in order to find certain information about our functions. Namely, it was where two curves intersect or where they cross the x-axis, where the zeros are. In order for this type of problem to find an output given an input, we can go to the same menu, a second trace, and if I want to find an output for a given input, I choose option 1 for value, and then I just type in the value that I want. So we know that x equals 80 because the car is traveling at 80 miles per hour. Hit enter, and I'll get the y value. Now you'll notice that there's quite a difference in the values that we got when we ran this and from when we did the just straight up putting it into the home screen. And you'll notice this one has about 12 decimal places, give or take. And this one we only use 3 decimal places, so that will affect our value. You want to just be sure that whatever directions you're given as far as rounding, you follow that. That's part of the mathematical practice of attending to precision. You would also have to make sure you pay attention to whether or not decimals make sense and whether or not negative numbers would make sense. So depending on where you do your calculation at, I'll use the one that we got from the home screen, but remember the other part of attending to your precision is answering the question that you're asked. So since I was asked the question in words, I need to answer in words. So I'm going to say the fuel economy is, and then I need to look back to my problem for the unit. It's in miles per gallon. So my fuel economy is 21.952 miles per gallon at 80 miles per hour. So again, I took all of the information from the problem and used it in the context, and I wrote my answer as a complete sentence using the context of the problem. Question number 2 asks, which is the best speed to maximize fuel economy? Hopefully you remember from all of the discussions we've had about graphs is that the maximum or minimum values of a quadratic function occur at the vertex. Therefore, anytime I see any kind of word that talks about maximizing, minimizing, biggest, smallest, any kind of thing that would imply that there's a maximum or minimum value, that's telling me that I need to find the vertex in order to answer the question. So one way that I could do this is algebraically, and I notice that my function is written in standard form, Because it's written in standard form, I'm going to use the h equals opposite of b divided by 2a formula. And so I'll take my b value, opposite of b is negative 0.746. And then I'll use 2 times my a value, negative 0.008. Please notice too the fact that I'm using a parentheses in the denominator. You will get the wrong answer if you do not do that. Times negative 0.008. It might also be better if you just put the do the 2 times a separately and then do the calculation. It's up to you. Just make sure you're careful with it. And so, I get the answer there, 46.625. That's my h value. And again, we have to read really, really carefully. You'll notice that, again, x represents speed. I was being asked for the speed. So therefore, the x value of the vertex is going to answer that question. However, if the question was asking me to find the maximum fuel economy, then I would have to find the k value of the vertex and answer with the y value. So again, very important that you read the questions carefully and you pay really close attention to what the definition of the variables are. Now, again, you could also use your graphing calculator to do this. And so I'm going to go back to the graph, and I'm going to do second trace, and you'll notice that I have options 3 and 4 for minimum or maximum. Because I have a parabola opening downwards because of the negative a value, that means we have a maximum, so I'm going to choose 4 for this one. But if the parabola were opening right side up, opening upwards, and had a positive a value, then I would choose the minimum. So I choose maximum, and just like before, when I'd found zeros, I need to tell the calculator where to look. So it helps if you physically put your finger down on where the maximum value is, and then paying attention, you can use your X's as a guide if the blinky is off the screen. But I'm going to move blinky until he's to the left of my vertex. Hit enter. Move blinky to the right of my vertex. Hit enter. And then hit enter the third time. And there I get my vertex. And again, you use the X or the Y depending on what the question's asking you to find. And again, I'll use the value that I found from the function algebraically to answer the question. So I will say that uh, 46.6 miles per hour. That will be the speed that maximizes my fuel economy. So, now you know a couple ways to use the quadratic function. You know how to find an output value given the input and how to use the vertex to help you answer the questions. And again, I can't emphasize enough, You have to read what the variables are defined as, and you have to read carefully what the question's asking you for. It's absolutely useless if you answer the wrong question, even if you answer the wrong question correctly.